Let's transform condensed formulas into skeletal formulas. The first thing you want to do is to identify the longest carbon chain. In the first example, it has 4 carbon atoms. Now, we draw the skeletal formula for those carbons. It should look like this. Each end and bend in the line represents a carbon atom. Next, let's add the substituents. We have a chlorine atom, a methyl group, which is CH3, and a bromine atom. Let's place them on the skeletal formula. As you can see, a CH3 group is represented as a short line branching off the main chain. The end of the line always represents a carbon atom, so we don't need to write CH3 explicitly. Only substituents that don't contain carbon, like halogens or NO2 group, are written out. Lastly, we add bromine, and our skeletal formula is complete. Now let's repeat the steps of the different compound. First, find the longest chain. This time it has 7 carbon atoms. Then, draw the skeletal formula for those. Everything else is substituent. We have 2 CH3 groups on the same carbon, so we drew 2 lines from that point. Each end represents a CH3 group. Next, we add the NO2 group and another CH3 group. It's very important to place substituents on the same carbon as in the condensed formula. You can always add numbers to make it clearer. The last example you can try it yourself and then check the answer. So first, mark the longest chain, it should be 10 carbon atoms, and identify the substituents. Then draw the skeletal formula from the main chain, and finally add the substituents. On the first carbon, there's a CH3 group, so we draw a line. On the first carbon, we have 2 bromine atoms, so we add both. Next is a CH2CH3 group. It contains 2 carbon atoms, so it should look like a short chain, and you should see both carbon atoms in the skeletal formula. On the same carbon, we also have another CH3 group. On the 8th carbon, we have another CH2CH3 group. Thanks for watching and stay tuned for more organic chemistry tutorials.